Okay, so we are using the right triangles, and we're going to continue using trig like we did yesterday, okay, as if we're just going to apply it to more of a real-life problem. We're talking about angles of elevation and depression. We did one like this yesterday when we talked about how Dakota had to use his theodolite to look at the top of the cliff, okay? Well, that angle created by the ground and the top of the cliff was an angle of elevation, okay? An angle of elevation is the angle between the line of sight and the horizontal line, okay? Kind of like an elevator goes up, okay? It elevates above the horizontal. So let's say that you are out in the woods at a cabin, okay? And you're sitting on the porch. This is your horizontal line of sight. That's your horizontal line of sight. Okay, you hear something in the distance and you look up, and on the cliff you see a deer. Okay, so you elevate your eyes up to look at the deer. Okay, this is your new line of sight. The angle created from your horizontal line of sight and your new line of sight is called an angle of elevation. Okay, it's called an angle of elevation. It has to rise up above the horizontal line. Okay, it's called an angle of elevation. If I were going to look at this up sign up here on top of the door, I'm looking straight ahead. I can see the NJHS bulletin board, but then I want to look at the up sign, so my eyes have to elevate up to look at it. Okay, the angle created between my two arms is an angle of elevation because it rises above the horizontal. Okay, all right. So let's do this example. It says the crossbar of a goalpost is 10 feet high. If a field goal attempt is made 25 yards from the base of the goalpost that clears the goal by 1 foot, what is the smallest angle of elevation at which the ball could have been kicked to the nearest degree? Okay, so we have a goalpost. Okay, and it says that the crossbar is 10 feet tall, okay, and you have this guy who is 25 yards from the base of the goalpost, and he wants to kick the ball so that it clears the goalpost by 1 foot, okay? So what is created here? A right triangle, right? Okay, we have created a right triangle because the goalpost and the ground are going to make a right angle. And we want to figure out at what angle he's going to have to kick the ball to clear the goalpost by that 1 foot. So how high does it need to be kicked? 11 feet, right? And we have a right triangle, so we can use our trig stuff in order to figure this out. Only one problem: the height that the ball needs to be kicked is in feet, and he is in yards. So what should we do here? Multiply by what? 3. Okay. Well, you said multiply. I wanted to make sure you knew what it was. Okay, so we multiply by 3, which takes us to 75 feet. Okay? All right. So if we're going to use trig, what are we going to use? Sine, cosine, or tangent? Remember our SOHCAHTOA. Okay, so we're going to use tangent. And so we're looking for the angle. So it's the tangent of what? Okay, opposite and adjacent. So my opposite is 11, and my adjacent is 75. Okay? Yes. Because it was in 25 yards, and so I had to change it to feet. Okay? And there's 3 feet in a yard, so I had to multiply by 3. Yes. Because the goalpost is 10 feet high, and you want to kick it 1 foot above the goalpost, so that's why it's 11. Okay, so am I going to use regular? Yes. Oh, am I going to use regular tangent or second tangent? Second tangent, right? So I'm going to do second tangent 11 divided by 75. I'm using second tangent because I'm looking for the angle. Okay, so okay, so second tangent 11 divided by 75, and that's going to be 8.3. Now it says to round to the nearest degree. If I followed my rounding rules, I would put 8 degrees. But if I'm wanting to clear it by at least a foot, should I go down with my angle or should I go up with it? You should go up with it, okay? So he would need to kick it at least a 9-degree angle. All right, so that is angle of elevation. Now I want to talk about the angle of depression, okay? And your angle of depression is the angle between the line of sight when the observer looks downward in the horizontal line, okay? And so let's say you're at the fair and you're up here on the Ferris wheel and you see your friend down below, okay? Now, if you're sitting up here, this is your horizontal line of sight. But then you notice your friend down below, okay, and this is your new line of sight. Your eyes, instead of looking straight ahead, your eyes have to depress below the horizontal to see your friend. So the angle created with the horizontal line and your new line of sight is the angle of depression. Now, inevitably, people always try to make this right here the angle of depression, but it is not. Your angle of depression has to be made by your horizontal line and your new line of sight. So it has to be this one. It can't be this one down here. Okay? It can't be that. It has to be this right here. So it has to be created by the horizontal line and your new line of sight. Okay? All right. Now, your angle of depression and your angle of elevation have a relationship. If you look on the back page down at the bottom, I've drawn a little example here of what I'm going to show you. Both the angle of depression and the angle of elevation are either rising above the horizontal or depressing below the horizontal. What's true about a pair of horizontal lines? What relationship do they have? They're parallel, okay? And we have this line of sight in both cases. That line of sight acts as a transversal, okay? And so what relationship do you think your angle of elevation and your angle of depression are going to have? They're going to be what? Congruent, right? They're going to be congruent. I'm sorry, I couldn't hear. Because they're alternate interior angles, okay? They're alternate interior angles. So your angle of depression and your angle of elevation are always going to be congruent. In fact, when you're doing these problems, you know, you could create yourself a little rectangle, okay? Your horizontal lines are going to be the same as are your vertical lines, okay? So you might have to transfer some information. So let's say they give you an angle of depression. Well, you could come down here and put it in the angle of elevation spot. All right, because they're congruent. All right. Okay, so let's do a couple of examples here. Leah is meeting friends at the flagpole in the park. She sights the top of the flagpole at an angle of elevation of 38 degrees. She knows that the flagpole is 25 feet tall. If Leah is 5.5 feet tall, about how far is she from the flagpole to the nearest foot? Okay, so a couple of things it tells us is it tells us that Leah is 5.5 feet tall. It says that the flagpole is 25 feet tall. And it says that she looks to the top of the flagpole at an angle of elevation of 38 degrees. Now, this is her horizontal line of sight. This is her new line of sight, okay? So her angle, the angle of elevation is 38 degrees there, okay? And we want to know how far she is from the flagpole to the nearest foot. Now, my only problem is that it tells me that the flagpole is 25 feet. She is 5.5 feet tall. Her angle of elevation comes from her height, okay? And so what should I do here for this segment? Yes? Okay, and so that gives me 19.5 right here. All right? And then her horizontal line and the height of the triangle create a right angle. So what could I use to figure out how far she is from the flagpole? To use sine, you have to know hypotenuse. It's going to have to be tangent, right? Okay? Because we have opposite and adjacent. So we are going to use the tangent of 38 equals opposite, which is 19.5, over adjacent, which is x. Now, what do we have to do? Multiply both sides by x. Okay, so I get x tangent of 38 equals 19.5. And then I divide both sides by the tangent of 38. Am I going to use regular tangent or second tangent? Regular tangent. Okay, so I'm going to do second tangent 19.5. Oh, yeah, just checking to make sure you're paying attention. 19.5 divided by the tangent of 38. What do you get? 24.95 something or other. Okay, it says round to the nearest foot, so what would it be? 25 feet. Alright, so that was pretty easy. The hardest part about that is you just had to take the 5.5 off the height. Okay? Alright, now let's look at the next one. You will probably see another one like this one, so pay close attention because you're probably going to see this again. It says, a plane flying at an altitude of 12,000 feet begins descending when the end of the runway is 80,000 feet from the point on the ground directly below the plane. Find the measure of the angle of depression to the nearest degree. Okay, so we've got this airplane, okay, and it says that it's at an altitude of 12,000 feet. That means if this right here is the ground, the altitude is how high up it is, okay? Now it says it's going to descend when the end of the runway is 80,000 feet. So it's going to begin a descent, and then here is the runway, okay? It says when the end of the runway is 80,000 feet from the point on the ground directly below the plane. So this right here, that's the ground distance, okay? That's 80,000 feet. So it's going to begin its descent when it is 80,000 feet on the ground away from the runway, okay? It wants to find the angle of depression. Where is the angle of depression? Yes.
Right at the angle. Right at the
Is it this right here? No.
no.
It has to be created by the horizontal line, right? So this right here is the angle of depression. Okay? That is the angle of depression. Now, this angle of depression is the same as the angle of elevation. So could I move the x down here? Because they're going to be congruent to each other. Okay? All right. So now I've got everything in my little triangle and I can solve. Now remember, your altitude and your ground are going to make a right angle, so there's my right angle. So what am I going to use to find this? Okay, I'm going to use second tangent, but how am I going to set it up? Tangent of x equals what? 12,000 over 80,000, right? Okay, can I get rid of those zeros right there? Sure. Okay, so yes, this time I am going to use second tangent. 12 divided by 80, and I get 8.5. And it says round to the nearest degree, so what would that be? What would that be? 9 degrees? 9 degrees. Now, let me ask you this, or let me tell you this. I always give a problem like this on your test, okay? And inevitably, instead of giving me 9 degrees as the answer, people give me 81 degrees. And they give me 81 degrees because they use this as the angle of depression. That's not the angle of depression. The angle of depression has to depress below the horizontal. It has to be this, which is the same as the angle of elevation. But let's think about the reality of the answer that somebody would give me if they gave me 81. Would you want to be on an airplane that dipped 81 degrees to start landing? No, you would be in trouble, right? You'd be almost going straight down. So sometimes you got to think about, okay, does this answer make sense? All right? Okay? Okay? All right, so any questions? Yes? You should hit second tangent, 12 divided by 80, because you're looking for the angle, so you have to use second tangent. Okay?